Welcome to Minimaths at DECV, where we learn a lot of maths in a little bit of time. This session is a review of what we learnt last time, and we talked about the decimal points and the numbers that come to the right of the decimal point that are always fractions. They are always tenths, hundreds, or thousands because our whole number system is based on groups of 10, and the decimal number system is based on groups of tenths. And let's have a look at what we know. We know that a 1 can be as big as a universe or as tiny as a pinhead. And we know that any whole thing can be broken up into smaller parts. In today's case, it's being broken up into decimal fractions, which are tenths, hundreds, thousands, even up to billions. And here are the different ways that we can express tenths: as a word, 1/10, as a vulgar fraction, or as a decimal fraction. So they appear in our number system in those forms. We have one whole thing here broken up into equal parts. And you can see a tenth in comparison to 100 is quite a lot bigger. And that's where most people get tricked on decimals. They don't realise that when we go into the decimal counting system after the decimal point, our fractions are getting smaller. And we all know our number chart really well, where the decimal point is always after the ones and before the tenths. And it's like a marker that says, well, we've run out of whole numbers. Let's break the numbers into 10 equal parts, 100 equal parts, or 1,000 equal parts, and we're getting smaller. So you will always see the decimal point between the ones and the tenths. If you remembered those important ideas about decimal fractions, congratulations, because they are important. We then spend a bit of time playing a game. The game is called Treasure Quest Decimals. If you look at our grid here, it's broken up into 100 equal parts. That makes it a grid that we count in the hundredths. Then we had a go at placing these decimal numbers, which is 0.78. We never say 78 because 78 is 7 tens and 8 ones, and they're in a different column on the other side of the decimal point. So we say 0.78 or 78 hundredths. I thought it might go about here somewhere, but let's have a look. So how the game works when you go to play it yourself, your target number is shown here. Your job is to locate this on the grid. So if you can imagine where 0.5 would be, I think it could be about there. And of course, 0.5 is exactly half of that grid. So it is quite a bit of fun. It's on Math Playground. It's Treasure Quest Decimals. And we had a lot of fun finding where the decimals might go. So I have to put 0.42, and I thought it would go somewhere here. That's maybe about there. So close. And then at the end, there are all the decimals we had to look at. We then played a game where we worked out which number is greater. So what we did, we compared the two numbers. And we've got one here and one here. It's all the same. Decimal point, then we've got no tenths, but we have 1/10. The minute that you have 1/10, the number is going to be bigger. And we did the same for this one. We looked at that and that, exactly the same. The decimal point tells us we're working in tenths. I looked there, I had 7 tenths there, but if you have no tenths, this number here will be greater. Pretty easy to work out once you know how. why we put this in, a lot of people will automatically say this is more because it's got more digits, not in decimals. In decimals, you have to definitely look at the values. So 25 is the same there. Interesting, the tenths are the same there. But when we look at the hundreds, I have 9 hundredths there and no hundreds there. So this number is more, even though it doesn't have as many digits in there. I think I tricked myself here. Yes, when you're solving problems, you need to read the question. So here is less. So compare the numbers, 405. The decimal point means we've now got a tenth here, and we've got a tenth here. Well, so far the numbers are identical. I've got 100th here, but no hundredths there. So this number here has to be less because this number has got hundreds, and a hundredth will be bigger than this teensy weensy little thousandth there. All right, and so we went on which number is greater. I think you should have it by now. Exactly the same. There are no tenths, but we have 5/10 here, so this one is greater because 5/10 is greater than no tenths. And which number is greater? Usually apply the same rules, all the same, so no contest. We have 0/10, but 9/10 will always be bigger. And then we have the bigger number. Even though this has more digits, this has more value. And let's look some more. I think we can nearly get to the end here. And writing a number between. And if you think of your number line, it'll be breaking it up from our tenths, and we can put hundredths. I could even put thousands. Okay, and even a number like that would be between 19.2 and 19.3. And one of the last ideas we talked about is how we can write 4.5 as a decimal. And we know that 0.5 is 5/10. 5 is half of 10. That is a decimal. We know 2.3 is, 2 3/4 is 2.75 or 75 hundredths. And then the last one is 8.25 or 25 hundredths. So that was a bit of a trick one. That's our session from last week. Go and find Math Playground Treasure Quest Decimals and have a good time playing with decimals. Bye.